Hi, my name is Hannah and I'm going to give the presentation of orthostatic testing. Okay, to start off, we hypothesize that if a subject changes position after 5 minutes from laying to standing, their heart rate and blood pressure should increase. For a little bit of background info, cardiac output is the volume of blood pumped from the heart in 1 minute, which is calculated by stroke volume times heart rate. The stroke volume is affected by the end diastolic volume and the end systolic volume. According to Myriad and Hone's Anatomy and Physiology 9th edition textbook, stroke volume and blood pressure are correlated. Therefore, measuring blood pressure is a good way to see if stroke volume is increasing or decreasing. Heart rate is the number of beats per minute and is controlled by the sympathetic and parasympathetic nervous system, which releases norepinephrine to increase heart rate. Standing up affects heart rate because blood pools in the lower extremities, resulting in baroreceptors sensing change in blood pressure, and the sympathetic nervous system is initiated to modify cardiac output unless the individual has orthostatic hypotension. A person has orthostatic hypotension if systolic blood pressure decreases more than 20 millimeters of mercury and diastolic blood pressure decreases more than 10 millimeters of mercury. For our methods of this experiment, we started out gathering necessary equipment, which included Logger Pro, blood pressure cuffs, a pulse oximeter, computers, and a heart rate monitor. We used the right arm for all blood pressure measurements, and the pulse oximeter was placed on the left index finger. Test subjects started lying down, with their blood pressure taken and heart rate recorded every 30 seconds with the pulse oximeter. After 5 minutes of the supine position, the subjects stood up as quickly as possible, with blood pressure and heart rate immediately recorded. After standing for 5 minutes, their blood pressure was recorded again. For our results, as shown in the graph, heart rate increased with subjects transitioned from supine to standing position. There is strong statistical significance between supine and standing heart rates with a p-value of 0.00542. We then compared systolic blood pressure, and as you can see, the average increased from supine to standing and decreased after 5 minutes of standing. There was no statistical significance between any measurement 0, 5, or 10 minutes, with p-values of 0.0754, 0.134, and 0.768. Lastly, we compared diastolic blood pressure. From 0 to 5 minutes, the blood pressure increased after standing quickly, and after standing straight for 5 minutes, blood pressure increased again, but only by 0.2 millimeters of mercury. There was no statistical significance in the diastolic blood pressure at any times, with p-values of 0.0919, 0.944, and 0.074. To conclude our experiment, no subjects had orthostatic hypotension because their heart rate was greater than their stroke volume. Also, we concluded that blood pressure is increased because of heart rate, and heart rate counts for higher output than stroke. There was no statistical significance with blood pressure at any times, but there was a statistically significant difference between heart rate from the supine to standing positions. Limitations on our experiment could have been the faulty devices, as we had blood pressure reading problems when in Logger Pro. Also, for future experiments we would like to conduct would be norepinephrine level measurements of a person sleeping versus waking up and seeing the effect that has on heart rate. These are our sources, and I hope you like the presentation.